Raise your hand if you've ever flown a drone before. Raise your hand. Now keep them up if you've ever flown a drone for science before. And that, whatever that means to you, science. Excellent. Now, this is going to get more and more common as we go into the future because drones are becoming a really amazing platform for scientific research. Drones can collect lots of data, do lots of monitoring, and all sorts of data. And the types of data that you can collect really depend on the sensors. Now, cameras are typical, but what's really exciting about this new realm is that basically anything lightweight and low-powered enough as a sensor can be put on a drone and used to collect and monitor all sorts of information, which is really exciting. Now, I spend a lot of my time thinking about this gap right here, and that's the gap between field-level knowledge and global challenges. This looks particularly exciting in the face of climate change, where we do know a lot on the field level. We can monitor, measure, all sorts of things on the field level. We know a lot about the complexities of greenhouse gas emissions. However, when we scale up our knowledge from the field level to the global scale, we lose a lot of that information. And at the global scale and the regional scale, that's where a lot of the decisions are being made about these environmental challenges. So it's really important to bridge this gap. And I believe that drones can really be an exciting tool to help us start to bridge this gap between these two scales. So what does that look like in a practical sense? You say, I measure greenhouse gas emissions. Well, that looks kind of like this. I'm out in the field monitoring greenhouse gas emissions from these static chambers here. There's a lot of equipment. There's a lot of time for dancing. It's all very exciting. But this really just highlights the fact that it is actually really expensive and time-consuming to monitor greenhouse gas emissions on the field level. This is just one static chamber on the field. And if we can imagine just on the field scale, let alone a regional scale, on the field scale here, you can see that actually this sort of single-point collection method is not very scalable. That's just one of the chambers right there in the field. It actually takes many chambers to get an idea of what's happening on just the field scale. So again, sort of extrapolating this up to those sort of regional, landscape, even global levels. This is a Landsat imagery. You can imagine it's not very effective, not very efficient. We can't actually monitor all of this area as closely as we can on the field. However, remote sensing techniques can actually help us bridge these scales, I think. However, using Landsat, when we go back into our field-based site here, you can see this is an agricultural field. Maybe you can't because the resolution is so terrible. This is where I think that drones actually can really help us out. So, what does this look like? Here I am checking out the sensor on the drone. The drone we fly with two different cameras, an RGB camera and a near-infrared camera, to give us a couple different sort of spectral band combinations. Taylor is logging our flight plan as we speak. And then it's very simple. You just throw it into the air, and it follows the flight plan exactly, taking overlapping images that we then, after the flight, can mosaic together to get a better picture of our field landscape. And that's exactly what we see. We get high-resolution images. We're talking like 3 to 5 centimeter pixels, very high resolution. You can already see at this scale that you can really actually tell what's happening on the field. It can give us a lot more spectral signals. We can start to extrapolate and interpret and approximate what's happening on the field scale in terms of greenhouse gas emissions. And it's not just spatial, but the ease and flexibility of flight means that we can actually do things like this, fly 1 week apart and capture events like manure spreading that happens on the field to sort of start to target these hot spots or hot moments on the landscape. This is the same image again. This is NDVI imagery, so this is highlighting sort of vegetation, drawing our attention to high-density vegetation areas. And this, again, is just another way, another tool that we can potentially use to help us make these landscape decisions. And it's not just imagery. We have the capabilities, because of the overlapping way that we take the images, of getting digital surface models such as this, where we can actually tell elevation, which becomes really key when you have these complex landscapes. Here's a wetland with neighborhoods on one side, agricultural fields on the other. This is actually a 3D model from the point cloud from these overlapping images. And this allows us to do things such as flood analyses, which is very important in this area because it's a very flood-prone region of Vermont. And here we can actually see what a sort of large-scale flood event would look like on the landscape, and we can make management decisions based around these environmental events that, all through using this high-resolution drone imagery. That just touched the surface. Here's a bunch of words that showcases other ways that our lab is using drones to monitor. And I want to thank everybody. And think I'm out of time.